English teachers some days. All right, so I just started the recording. Sorry for those of you who are out in the sun on the beach tanning yourselves. We're graphing sine instead of cosecant because they're reciprocals. And the one graph is going to produce the other for us. Where does sine start?
Middle.
Starts in the middle. And you can see why at the beginning of this unit, I gave you a few sine graphs to practice. Because you need to be good at it. It needs to be quick. It needs to be a skill that develops so that you can move on from there. So that's what you want to produce right away. And by now, you're excellent at that. So that is not the graph of cosecant, but it helps us discover the graph of cosecant. So we'll see who can be first in line here, because I've already heard it talked about today. I have the value of sine here. What's the value of sine right here? 0. What's the reciprocal of 0?
Undefined.
Undefined. And so if I have an undefined value, I will draw vertical asymptotes. In fact, everywhere where the graph is equal to 0, I will draw vertical asymptotes. Still not the graph of cosecant, but really gives me a good idea what it's going to look like now. Now we're going to plot some points, okay? We're going to go back to this reciprocal idea. What is the value of sine right here? 1. What's the reciprocal of 1? Positive 1. Good. So sine and cosecant, they share that coordinate right there. We know that, okay? And then let's move along, okay? It's good. It's good. It's good to laugh. We need to laugh each day. It's good.
Anyway.
Yeah, and it's okay to be laughed at. All right. So I was subbing in class yesterday for an 8th grade class, and I was trying to read the names. I was reading the names. I was like, okay, is your name 2 syllables or 3 syllables? She's like, I don't know what a syllable is. No, don't say that, because everybody started looking like, what do you mean you don't know what a syllable is? Like, I don't know what a syllable is. I just say things. No. And then she went quick. She's like, so what is a syllable? Okay, so like number 6. That's 1 syllable. 7. I don't get it. I'm like, okay. We're just quitting. All right. All right, so let's figure out the rest of the graph. How about the value of sine right here? Is this a big value or a small value? Small. What's the reciprocal of a small value?
Big.
A big value. So you can see wherever a sine has small values, cosecant is going to have really big values. Now we're going to go over to Gina again. Gina, what is the height of the function here?
-1.
-1. And what's the reciprocal of -1?
-1.
Excellent. And so you can see that this is going to produce the same thing. It's just the bottom part of the graph. And so the blue part of the graph I'm drawing, that is, in fact, the graph of cosecant. It has those U-shapes, and they're separated by these vertical asymptotes. Separated by the vertical asymptotes. And what I love about this is, again, it's the unit circle coming to life. Notice sine always stays between what 2 values? 1 and -1. Where does cosecant never go?
1 and -1.
See what I mean? So in terms of its reciprocal nature, it really is all laid out there for you, which is really cool. Instead of graphing secant, what am I going to graph? Cosine. Go through the process. We all know what cosine looks like. You can understand why I'm going to be shorter with my tick marks. I'm not going to put them all the way at the top or bottom because I need to make room for the rest of it. And once you have that horizontal structure drawn out, you can then go ahead and, draw your graph. Remember that cosine starts at the top. Why does cosine start at the top?
greatest value.
Why? Because the terminal point for 0 for cosine is 1, 0. And is cosine the x value or the y value? The x value. So the x value here is 1. That's why it starts up at 1. So again,
How do you know that the terminal point is 1, 0?
So for an angle of 0, so the x is our angle. So for an angle of 0, the terminal point right over here is 1, 0, right?
Oh, yes.
See what I'm saying? So that's why cosine starts up at 1.
0 is just a straight line. So okay,
Yep. Good. All right. So now once we get that, we go ahead and we draw our asymptotes. They go right through the same spot. And you can see that your graph of secant is going to look very, very similar to the graph of cosecant. It's time to interject our phrase for the day. So if you send me a message, and the phrase for today is, prison is better than the Packers. Prison is better than the Packers, okay? So, yeah, it is true. We only spit out facts here in this class. Flip it on over. We're going to skip this stuff. You don't need it because you're super smart class. In fact, we're going to skip this example right here, and we're going to do these 2 examples, and you'll be ready to do your assignment. So now let's implement some transformations into these 2. For the first one, we're going to do 2 transformations, and for the next one, we're going to do 4 transformations. So the first one, instead of graphing -3 secant of 2x, I graph y equals -3 cosine of 2x. Sometimes people say, Mr. Gens, what if I can't remember that cosine and secant are reciprocals on the test? Yeah, you just get the problem wrong. So do remember which ones are reciprocals. That's important. I can see that my amplitude is 3. So I'm going to mark 3 there and -3 below. And then, what is the period? Pi, because I take 2 pi divided by 2, and I get just pi. So I'll mark that out.
Oh, can you explain?
The third tick mark?
Yes, please.
The third tick mark is always 3 times the first tick mark.
Okay.
So notice that the middle tick mark is half of the last one, and then we do half again, right?
Yeah.
So then just take 3 times the first, so it's 3 pi over 4. So there's probably 1 or 2 on your assignments that get a little bit tricky, and we could definitely talk about those afterwards if you want to set that up. Like, for example, if the period ends up being like 2 pi over 3 or something, sometimes that's a little tricky for people to figure out. Okay. All right, now what? Tell me what to do.
Graph the.
Okay, graph cosine. So
starts at the top. Starts negative. Yeah,
so it's negative because I got that negative sign there. Yeah, it's going to do that vertical flip. Good. So I'm going to go ahead and put some dots here. Good old dots.
This is our ghost graph, right?
Yeah, kind of, yeah. I called this one the skeleton graph. Not because it's really any different than a ghost graph, just because it makes me feel a little bit more like Halloween or something.
You like Halloween?
I do. I'm a big Halloween fan.
Halloween is probably my least celebrated.
I always had this desire that when my kids would celebrate Halloween, we would clean out the garage and we would make like a haunted house through it. That in order for people to get the candy, they would have to travel through the haunted house.
When you have grandkids.
Yeah, I know. Like we live in an area of town where nobody comes there, so I'm like,
oh nobody
man.
trick or treats.
Yeah, maybe I need to just go bigger to draw people in, huh?
Where do you live by?
So this is an Otana.
I want to tell you.
Oh, well, you live in Otana. Yeah, that's right.
Not saying.
No, that sounded cool.
No, all of a sudden you guys all show up on like a Friday night to egg my house.
We'll show up on
Here's
Halloween.
that dumb math teacher. Boom, take that, idiot. I know how it goes.
White pages.
Ding dong ditch, ring the doorbell, run away, right? Or you get the super soaker as soon as I answer the door. Boom, you get
I
me.
think you'd outrun half of us.
Thank you, Gina. I'm athletic. I am. I like.
You would like catch up to me.
Yes, I could.
Slow.
Thank you. All right. I still got it. Thank you. All right. So now that we got that, draw your asymptotes.
I think I'd be scared if you were running out.
Running
there.
at you. It would be like the current events where teacher shoots kids that came to Egg's house.
That was one of the best things when I was a camp program director. One of the best things is that every day, like after you got done with kind of your learning stuff at like 4 o'clock, it was time for a large group game. And you played with the kids, you know what I mean? So if you were playing kickball, then you played. If you're playing tag, you played. So you always got a chance to run around. Life is a lot more fun when we play games. So, which reminds me, if anybody wants to have a fun flex day, let me know and we'll invite you on over.
Your email today.
We'll invite you on over. Whose flex are you in?
Miss Jeffrey.
Are you coming on over?
No, we have a snack Friday.
Snack Friday? Okay, I got big time. Somebody else will be invited. All right, our last example, then you can start your work. We're going to switch this one. I don't want to do this example. We're going to do y equals -4 cosecant of 2x plus pi over 2 plus 2. So we didn't do a cosecant one, so I want to make sure we build that in. So I won't make any jokes during this time because this one's a little bit more involved.
So that's just all we do for this.
Yep,
like-
yep, you're done.
Okay.
That's it. So I'll try to maintain focus through this whole piece here. Notice I have 4 phase shifts, or I should say 4 transformations that's taking place. And I always start with the vertical, and then the amplitude, and then the period, and then the horizontal shift. So we'll take it piece by piece. What is the vertical shift? Yeah, it's up 2. Okay, let's do the 2 on the end. What is the amplitude?
4.
Up 4. And what is the period? Just pi. Good. So we've got those 3 in place. Before I do the horizontal shift, I want to start mapping that out. And just note that if the vertical shift is 2 and the amplitude is 4, what is going to be the highest spot on the graph? 6. What will be the lowest spot? -2. So I want to kind of aim for when I set this up that all of 6, that's my highest spot. Okay, so I don't want to put 6 way at the top, otherwise I won't see the graph. So then from there, I'll go by 2. So I'll say that's 4 and that's 2. So each tick mark will be 2, and know that I have this new axis sitting here at 2. So I go up to 6 and down to -2. Any question or concern so far? Okay, so my good friend Dorothy, she was looking at this and she was like, well, Mr. Gantz, this is going to get really crazy. Like, you're going to have ghost graph on top of ghost graph on top of ghost graph. I said, you're right, but we're going to figure out a way to work that out. So don't worry. Let's just lay out our period right now, which is pi, pi over 2, pi over 4, and 3 pi over 4.
Is there a reason why they're not like spread out more or like?
Yeah, I just decided I didn't like that I made the graph so wide. So I think when I originally did this, I planned on making like more than one period or something like that. I can't remember. It's probably watching
You
Tim
could have
Wolf's
multiple
games.
periods.
Yeah, so you could, well, we could stretch it out so you show 2 pi, so we could see 2 revolutions, you know what I mean?
Oh, yeah.
So we could just show more, okay? All right, now let's identify the horizontal shift. In order to identify the horizontal shift, I take the inside, so 2x plus pi over 2, and I set that equal to 0. When I set that equal to 0, I subtract the pi over 2 from both sides. I get 2x is equal to pi over 2. And what happens when you take pi over 2? Whoops, sorry, negative. What happens when you take negative pi over 2 and divide it by 2? Negative pi over 4. Now we're going to avoid the ghost graph altogether here, okay? And this is the trick to cleaning up your graph, okay? This is something that's going to help you out. If it's a cosecant graph, do I want to graph sine or cosine?
Sine.
I want to graph sine. Does sine start at the max, min, or middle? Middle. Is it going to start by going up or going down?
Down.
Okay, is everybody clear that I would want to start right here in the middle and I would then go down?
Yeah.
So what we're going to do now is we're just going to apply that horizontal shift. The horizontal shift is negative pi over 4. So I'm just going to take that starting point. Instead of starting here, I'm going to start here. Hey, stop that. I'm going to start right here. So I'm just going to move that back right away. And then I'm going to, from there, go down. Back up to the top, down to the bottom. So if I just move my starting point, that should give me enough information to be able to figure out where the rest of the points go from there. And that way I don't need to make that ghost graph. I've made the transition. Some of you may ask, well, Mr. Gibbs, why didn't you show us that the other day? When I have shown that in the years past, people have not been able to put it all together. Half the class has and half the class hasn't. It just gets confusing for people. So last thing is that before we always put the asymptotes where it crossed over the x-axis. Well, now we put it over where it crosses the axis of rotation. So it's not always the x-axis, it's always your axis of rotation. So that means that my asymptotes are going to go here, 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 and here. And then once those are in place, I could draw my U-shapes. Please make sure that your U-shapes go at the correct height. So the height should be at -2 when it's on the bottom, and it should be at +6 when it's on the top. Sometimes people draw their U-shapes right up against the x-axis. That is not accurate, and I will deduct points for that. And as you glance at it, I get it looks a little bit kind of messy and confusing, but without a doubt, if we were to put that on our calculator, that's exactly what we would get. And that's it. You have 4 problems on the front of your sheet, 4 on the back. You guys are ready to go.
One lesson left?
Yeah.
When's our test next?
Wednesday. Yep. I'll get your study guide tomorrow. We're going to set a record on this test. We're going to have everybody over 90%. What do you think? Half of everybody will score 100% on this test. Mark my words.
We can do it.
What if they don't?
What?
What if they don't?
Then I guess you guys just aren't as good as the other
I
years.
lost my favorite pen.
Do you think you're not as good as the other years?
I just love to see.
I believe in us. I don't know where it is. Sorry. That was you. I'm sorry.
Some people use
Black and white.
things and find them.
Kenny, you don't ever wear glasses, do you?
Things and find them.
Now the week is almost over.
Dang.
You don't usually have to hear it back, do you?
Actually, I'm not gonna write it.
Last day by myself.
Something seemed different today.
Oh, really
With my therapist.
Oh, I served your brother penis the other day. Or
I
like
miss food.
the other week.
I have eaten hot dogs for the
Really?
last week. Hot dogs, frozen pizzas, Miss Jerry's mac and cheese.
Mrs. Jerry's mac and cheese is so
And my grandma
good.
makes
Wait, do you,
cinnamon
have you
rolls.
seen that warming up or did you put it in like a crap platter? Is that, okay.
Answer keys are posted up here and answer keys are online.
Well, I made it, and then I've just been reheating the leftovers.
Yeah.
You know what I mean? So it's not like it's been sitting in the crock pot the whole time. So that would be bad. What?
Nothing. It's sign.
It's Mr. Gens. Still need somebody 8th hour. I prefer the math class if I can. Mr. Pagel, and if not, I'll take Ms. Scobbers. All right. I will,
I was playing that song last night.
if you have an office helper, you can bring it up to me, otherwise I can just stop down. I'll be coming down that way.
Horizontal shift. Yes.
How do we know?
Awesome, thank you.
It's just X.
Yep, no problem. Bye.
So is this side.
Yeah.
What is this one?
It's like it's secant, SEC.
Wait,
Did
what?
it? It's a bit weird, didn't it? Why'd you go for 3?
Did you not?
Oh, there's 2 5.
Why'd you go for 2?
Because, okay, the vertical shift is up 1 and the amplitude could be 2. 1 plus 2 is 3.
I tried the question.